Okay, the first step is going to be to turn on the argon ion laser. This is the power supply for the laser. We're going to turn it on in a couple of steps. First, we turn on the mains power. Then we turn on the power to the laser head. We haven't yet turned on the laser. There's a warm-up sequence that has to take place first. Finally, when the laser start light comes on, we can turn on the power. And on it goes. And it's telling us it's using about 25 amps, and it's producing about 120 milliwatts of power. Okay? So, the laser is on. Okay, here's the optical system, which we're going to set up. It starts with a laser here. Right now, there's an attenuator in front of the laser that blocks 99% of the power. So we can just barely see the laser beam. Well, I mean, it's quite bright if you look at it with your eyes, but on the video camera, it's hard to see. Right now, it's hitting a mirror and then reflecting off in this direction. And what we're going to do is to add the other optics to set up the rest of the system. So let's do that in a couple of steps. First, I'm going to get out and put in the iodine cell. Here's the iodine absorption cell. And I'm going to place it here in this holder. And it will just rest there. It's difficult to see in this video, but the iodine cell, the gas inside of the iodine cell, has a little bit of a red cast to it. That's the iodine. Now we're going to set up the other optics to bring the laser beam through the iodine cell. First, we'll set up this mirror, M2. And that's going to fold the beam back into the iodine cell. Okay? There we are. I'm going to lock the beam the mirror approximately into place, and then we can make further adjustments if we need to. So now the beam is going through the cell. Okay. We've also installed a beam block. The purpose of this is to block the laser when it exits the cell. Okay, very good. There are a couple more things we need to put in place. This is a band pass filter. Its purpose is to block any wavelength that is not at the laser wavelength. Well, it passes a narrow band of frequencies around the laser wavelength, okay? It turns out that the laser produces a very bright beam at the laser frequency, but it also produces a little light at other frequencies. Turns out, in addition to being a laser, it's also like a fluorescent lamp. And the filter will block out all the emission lines that we don't want. There we are. Very good. Okay. The last components we're going to put in are a lens to capture fluorescence from the iodine cell. Okay. And then the very last thing is a fiber coupler. This will capture some of the fluorescence and focus it onto an optical fiber, okay? And the optical fiber will bring the light to a spectrometer. So it's convenient now if I attach the optical fiber, like so, and then install the fiber coupler. And lock that in place as well. Well, everything's in place. The system should be pretty safe at this point. So I can take away the attenuator and have the beam at full blast. Normally, you'd be wearing laser glasses at this point, but since you're not in the room, I guess there's no hazard. Okay, there we are. Now, I'm not sure if you can see easily the fluorescence in the iodine cell. So I'm going to turn off the lights and then you should be able to see it. 1 second. Okay, now with the lights off, perhaps you can see the fluorescence. It's right here in the iodine cell, okay? Can you see it's like a yellow line crossing the cell? Very good. And now we're going to turn on the spectrometer and see if we can see the fluorescent signal. 1 second.